newsletter. So on Friday, after I write my newsletter, I'm then going to quickly turn on the camera and give a video version of the newsletter because all the news will be sort
Right
of
in your
roughly
head.
in my head.
That is
Yeah, yeah,
awesome.
yeah. And then, but then we can throw up some pictures and throw up some, we can show people some of the things that we're talking about.
That is awesome. Yeah, I realized that I need to do more than just daily space because daily space is very short episodes, and when I learn super cool things, people who get too close are not safe. I was playing games with some folks on Saturday and I threw down a meteorite and I was like, "Death to you, just like the dinosaurs." And then proceeded to like info dump about the Tanis fossil site.
So are you saying that you need ways to share information about space and astronomy with a wider audience? Is that what you're saying?
I'm saying I have to have that or I inflict science on the unsuspecting friends who
Yeah.
aren't
Yeah.
looking for that at that moment in time.
Yeah, exactly. It's a chance for us to just like, we're going to want to stand up on our pulpit and you know, just give long, lengthy explanations about all kinds of crazy stuff that we've just learned. And now we
Yeah.
have an audience that is into it, and that
Yeah.
way we can save our spouses and
Exactly.
friends from this. Yeah, it makes a lot of sense.
Yeah.
So
Have you
so
read
for
about the
all of you,
Tanis fossil site?
thank you. No, no, no. Please tell me.
Okay. So the Tanis fossil site, it's in North Dakota. It's 3,000 miles away from ground zero in the Yucatan Peninsula for the Chicxulub crater. And they have found a fossil bed that was formed during a tsunami in an ancient river from the Western Seaway that used to run up the eastern coast of the Rockies. So this tsunami carried and deposited it on the land where it beautifully fossilized over a period of minutes. Fish that had molten glass solidified in their gills, which means they were alive and breathing when they got hit by molten glass. It
Wow.
has tektites embedded in layers of dinosaur eggs with extremely well preserved embryos, tektites of the same chemical variety of those associated with Chicxulub. There are feathers 20 to, I want to say, 30 centimeters in length. So like this big centimeters that they believe came from massive dinosaurs. Yes, dinosaurs had feathers,
Heather.
humans.
Yeah.
And they even found like really well preserved dinosaur chunks that included like the skin, and in one case they think that the dinosaur was alive when it got killed by all the things related to the asteroid, washed ashore, and then fossilized right there. There's going to be a David Attenborough special on it April 15th that I have not yet figured out how to stream, and I'm really annoyed I have not yet figured out how to stream it.
Mm.
And it's just like an amazing site. There's a National Geographic article on it that is everything one would wish if they were like me. But channeling your inner 5-year-old, tell every 5-year-old you know, this stuff is cool.
That sounds awesome. That
Yeah.
sounds amazing. Okay.
Things we are not here to discuss today.
Not today, but this could be an episode.
Yeah, it
It
totally
has to
can.
do with
I
space.
during next week's hiatus, I think I'm gonna redo the plans for the rest of the year that we have.
So, right over the summer. Have we
No,
have
no,
we
no, no.
got all of our
So
like
I had planned out everything
right?
until 4th of July, which is when we normally go on hiatus.
Yeah,
And I think I'm gonna redo that.
to include dinosaur death. Right.
Well, and there was another couple of topics that came up in our discussion that have since fallen out of my brain that were more interesting than things that I came up with
Right.
last time. So yeah,
We're not here next week, right?
correct.
Okay. That is all. Just be
Okay.
prepared.
Yes, yes.
Okay. All right, let me know when you're ready.
Okay, I'm going to remember to open the Patreons before we start recording this time.
Yeah.
I'm not to be trusted, folks. I'm really bad at physical reality.
You need a checklist. Do you have any checklists? I have a lot of checklists.
I have a lot of checklists. I just don't have one for starting this show. Daily space, oh my goodness, that is so well defined. It's somewhat crazy.
Because I'm so naturally disorganized, I have no shame in using external tools to make me organized.
Yeah.
In fact, my favorite thing is a robot. Is just robots that just tell me what to do and when to do it and make sure that I do it. And won't let me go to the next step unless I've done it. We have a pile of automation running behind the scenes on Universe today, so that like it's impossible for me to make mistakes when I'm doing various live streams, that various pieces are, various titles of shows are placed into YouTube directly. The numberings are incremented, the file names, etc. Like everything that you would tend to make a mistake is, we do this stuff behind the scenes and sort of force it in.
Are you using
so that it's really hard to make
something?
We're using Zapier a little bit.
Dang it.
Yeah. Or
I did not
Zapier.
take French.
It's not French. It's either Zapier or Zapier. Which one it is?
I thought it was Zaps,
because they call them
Zapier?
They call them Zaps, so it's Zapier. Yeah, that's right, Zapier.
I didn't screw it up.
Yeah.
Okay.
Well, except you said Zapier, and that's like French. But anyway, and then we use we use our own custom. Chad made our own custom database in PHP that's using a framework that has all kinds of tendrils throughout the Universe Today platforms that takes stuff from one place, puts it over and prepares it in another place. All this stuff is all running automatically because I'll abandon it all. Right? Like I'm just like, go, just get it done. Just get the show. Let's move on. But no. Like, what about the transcript? What about getting the thumbnail right? What about giving people notice? What about pulling the stuff and mentioning it in the newsletter, et cetera, et cetera, et cetera. All the stuff that I will abandon in a heartbeat. So it's, so once you admit that you aren't organized enough for the task, then you can begin the recovery process and learn to love the robot.
I feel as I look at the Twitch stream and see Keeper of Maps changing the title because I forgot to correct the title before we went live, that I need to have Annie talk to Chad.
Yeah, so that's what I'm talking about.
Protect me from myself.
What is the new title?
Well, it had been Guest Talk. Angela Speck presents Here We Go Again and Again, the Great American Eclipses of 2023 and 2024.
That's not what we're talking about today.
No, it's not.
Yeah.
And so Keeper has now changed it to Astronomy Cast, which is fine.
Just big astronomy updates. No, updates. I'm calling it updates. Dark matter, dark energy, and the Hubble constant.
Okay. I'm out of coffee. I will live. All right.
And I've changed my intro a tiny little bit. We'll see if anybody notices.
All right. Are we ready to press record?
I'm ready.
All right. I pressed. It's not going. I pressed record, and it's actually recording.
Right on. Here we go. Astronomy Cast, episode 639. Updates to dark matter, dark energy, and the Hubble constant. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. I've been a space and astronomy journalist for over 20 years. With me is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well, and I do need to congratulate you on the anniversary of Universe Today, which is old enough to drink in the United States, I believe.
Oh, it's been doing that for 2 years. It's 23 years is Universe Today now.
Excellent. So congratulations. It's awesome.
Yeah. Apparently you just keep showing up every day and keep doing the same job, and eventually you've done it for a long time. And I found my life's purpose. I have no plans to change. I'll do this for another 23 years.
You know, I am happy to keep doing this with you for another 23 years.
There you go.
We are going to be doddering, gray-haired old people. So one of my favorite things to do early in my career was to ask the oldest astronomers I encountered what was the biggest discovery of your life? And I was shocked when I realized they consistently said galaxies. What do you think we'll be saying?
Oh, interesting. Photos from the surface of Titan.
Really?
Nah, I don't know. It's gonna be cool though, having a
I was
helicopter
going to
flying
go with
around
dark
Titan.
energy, which is kind of like related to the theme of our show today.
Well, speaking of, let's get into it. Knowledge moves forward, and so we must move with it. Today, we'll give you an update on some of the most fascinating, fast changing topics in astronomy, astrophysics, and cosmology. And we'll get to that in a second, but it's time for a break. And we're back. So, this is going to be just like a catch all of some interesting news that is pushing our knowledge of these topics forward. So, where do you want to start?
Let's start with why we need an episode like this.
Okay.
So,
Right. Wait,
so
are you saying like the early episode that we did that says dark matter and just like call it a day? That's not enough?
no,
Okay.
sadly, it's not. It's not. Back when we started this show, we thought, naive summer children that we were, that with improved observations from Planck, from continuing to look at supernovae, that we would see our understanding of the universe converge on a single value that explained the modern expansion rate of the universe in the context of the creation of the cosmic microwave background radiation and everything that has happened in between. And what we have instead seen is the two values had the error bars getting smaller and smaller and smaller, and they no longer overlap, and the difference between them is statistically significant. And what we have actually learned is there is something fundamentally wrong either with our understanding of the universe or our ability to observe things in many different ways.
And this term, this is the crisis in cosmology, which
Yes.
it gives it this really negative sounding name, but you talk to any astronomer about this and they're giddy.
Yeah.
They're so excited that things are weird and they don't understand and they don't know why this is the way it is and they can't wait to figure this out. And it means a genuine puzzle that they can finally sink their teeth into, because all it means is like better measurements at different times to get, to understand, is it a measurement problem or is it a physics as we don't understand it problem? And they love it. So I wish there was a better term than the crisis in cosmology, but
Well,
anyway, that's the term we're stuck with.
so the thing is, for people who are even at the more senior levels and not retired and shouldn't be retired in astronomy, we still have people in their 90s not retired. I'm excluding them from this conversation. For all of those of us who are below a standard retirement age, when we were learning astronomy, all the really cool stuff was done before World War II. You had the mapping out of the atom, where it went from the plum pudding model to our model today with the nucleus and the cloud. You had the resolution of quantum mechanics. You had all of this cool electromagnetism and quantum mechanics and gravity, and it didn't really speak together real well, but other than gravity not behaving, all the big stuff we thought had been figured out. And let's face it, most of us are just like, okay, gravity, this, we have a problem. And it was a really hard one most of us didn't want to be embroiled in, because string theory is ugly. But now we have an approachable problem that even observers like me can get in on and have opinions and thoughts and debates.
Yeah.
And
Why don't we try this? What if
it is
we
awesome.
just do that?
Yeah.
So I guess what's the update? Because I mean, we've done an episode on the crisis in cosmology. So what is the update?
So the update is that the folks who are using supernovae, this is Adam Rees's team out of Johns Hopkins and the Space Telescope Science Institute, the more and more supernovae they look at, it is still converging at a higher value. And they have gone through and they have compared their data with Cepheids in nearby galaxies, with supernovae in nearby galaxies, with Cepheids in our galaxy. And Gaia data is allowing us to understand those Cepheids as we have never understood them before. And Adam's team has figured out how to use the Hubble telescope in ways it really wasn't designed for, but works to make sure that they understand the photometry they're taking like it's never been understood before. And so observationally, there's nothing wrong with what he's doing to link Cepheids to supernovae, well, geometry to Cepheids to supernovae, and work our way out. All right, one day.
And so just to clarify this, right? These are observations of type 1a supernovae,
Yes.
which in theory give off a set amount of radiation when they detonate. So they act as standard candles. This is the most comprehensive survey of these supernovae to date. And it is
and of
continuing,
the Cepheids.
And of the Cepheids, right, at the same time, and is narrowing the error bars on both of them, and they are still not overlapping.
No.
They are more accurately disagreeing with each other.
Yes. So then we also have the folks that are looking at quasar timing in gravitationally lensed systems. So if you have a large cluster of galaxies, and then you have something behind that large cluster of galaxies, light that meant to go up here somewhere can get bent by the gravity to come down and reach us, and then light that meant to go down here can get bent up to reach us. And those paths that the light takes can cause the light to travel different distances, and it can also cause it to have multiple apparitions of the same distant object. And if that object happens to be a quasar, a quasi-stellar object with an active galactic nuclei, a black hole that is eating stuff, it can fluctuate in brightness over time. And we can use geometry to figure out the two path differences. And then we can use timing to see what's going on. And when you start using gravitational lensing of background quasars to figure out the expansion rate of the universe, it's matching up with Rees's team and the supernovae. So that data matches. Yay.
Right. All right, we're going to talk about this some more, but it's time for another break. We're back. So when last we saw our heroes, the supernovae timing had been refined. The quasars had been measured, and their timings had been refined close to and matching essentially what the supernovae are telling us. The Cepheids also been refined, and they were completely disagreeing with the supernovae and the quasars. So what does this mean then? Is this removing or really reducing the possibility that the measurements are wrong and that there's something more fundamental going on here?
It is looking more and more like there's something fundamentally wrong with how we're interpreting the Planck data of the cosmological background radiation.
Right.
And
so that's the other measurement. Sorry, and that's the measurement done by Planck to incredibly precise measurement.
Yeah.
That gives a different number than the Cepheid supernovae quasars. And like you think about it, like Cepheids are close, supernovae are in between, gravitational lens quasars are really far. That gives you a giant chunk of time. That gives you what, like 10 plus billion years. And that's all on one side. And then you've got the cosmic microwave background radiation, which is the first few 100,000 years after the Big Bang. And It's those two numbers that disagree with each other.
So this is where it gets interesting, because we are directly measuring the expansion rate by looking at supernovae, by looking at quasars, by looking at Cepheids that are distributed through space-time. With the understanding of the cosmic microwave background, what we're doing is we're looking at the point, I believe it's 0.003 difference in temperature, which reflects density in the CMB, and the size of those differences. And these differences arise from acoustic waves moving through the early universe, and the way they interacted led to what we call spectrum of spots, where you see a bunch of spots of one size, a bunch of spots of another size, and so on through the spectrum. And the spectrum in our models and the spectrum we see beautifully match. Then you take this measurement of the hot spots, and you're like, okay, that's dense. Those are going to become galaxies and clusters of different distributions. And you look at the cold spots and you say these are going to become emptiness. And you project your model forward and you measure right now what is the distribution of the large scale structure of the universe, the walls and voids that we see. You have two measurements. You assume from making other measurements what the geometry of space-time is. We believe the geometry is flat. And that's backed up by multiple sets of evidence. And when you run from cosmic microwave background at T equals 400,000-ish to modern day universe, and you figure out how the expansion rate has evolved to get from that to this, you end up with just a slightly slower expansion rate. But to do that, there is a whole lot of assumptions in the physics going on. And we know that the physics is weird because within the first few minutes of the universe, there was an epic of massive inflation that blew our universe up from super tiny to solar system sized. We know weird stuff happened. And there is this new idea that there was early dark energy. This is a terrible name. Terrible, terrible name. There was early in the universe some factor that rushed the expansion and then stopped.
But this is post-inflation.
Yeah.
Like this is after the cosmic microwave background radiation was released, but before the first quasars, the first really massive galaxies could form. There was this weird speed up and then slow down. Could it have been that just inflation carried on at an ever decreasing rate until it stopped inflating the universe, even after the cosmic microwave background?
So saying slow down is kind of, this is calculus. It's
less acceleration.
Yes. So it's a second derivative issue.
Right.
So it's like you put your foot on the accelerator, you go from 30 to 50, you pull back on the accelerator, and in the same amount of time, you go from 50 to 60. So you're still accelerating, but your acceleration is slowing down. And so...
But I guess, sorry, so what I'm saying, though, is like in the beginning of the universe, that expansion due to inflation is ludicrous. You know, the universe was something like the size of a volleyball, and then it was bigger.
Yes.
By a factor of, I forget what it is, like,
whatever the size of the solar system is.
Some enormous version of that. And that expansion happened in a fraction of a second. It happened in an incredibly short period of time. I'm going to use all these very generic terms because I don't have them in my head right now. But then it was still growing, but now it wasn't growing as quickly as it was in the beginning. Okay.
And then it was during this period that we can't see because the cosmic microwave background is opaque, that it's thought that early dark energy played a role so that the universe wasn't the size we thought it was when we're looking at that cosmic microwave background.
I want to know what this means and I'm sure you all do too, but it's time for the break.
Okay.
And we're back. So, Pamela,
Yes.
what does this mean?
Um,
Like,
it means
does it?
that there are good folks running interesting models that are finding that cold, dark matter with dark energy doesn't match the expansion rate of the universe, as well as a model that adds early dark energy to the mix. And as I wrote one of my friends this morning when she asked how I was, I think we know less about cosmology now than we thought we knew when I did my dissertation, and I'm glad I graduated when I did.
Wow, this is exciting then. This is good
It
news.
is. It
It's always
is.
better to know less. It's awesome.
Yeah. Yeah.
There's an analogy when you work on a project, like a large project, you go with this kind of naive enthusiasm for the project and you get into it. And there becomes this moment of clarity when you're
Yeah.
like, oh, now
Yeah.
I know what I didn't know before, which is how much I don't know yet. But you didn't even know that in the beginning. And you get to this point where, and that feels to me like that's like the halfway point. And then the 90% point is when you now know all the stuff that's left. And now you just have to do the work. But it still
Yeah.
takes half of the time.
Yeah.
So so the halfway project is when you finally understand what's left to do.
Yeah.
And we're at the point now where at least we know what we don't know, what we don't know, which is exciting.
Yes.
As opposed to not knowing it. I'm sure none of that's making any sense. But how will we get an answer to this then? How will we sort this out?
That is always the question. I mean, we need simultaneously both improvements in our understanding of the cosmic microwave background distribution, which we need for a variety of other reasons. If we can get high enough detailed observations, we can start to rule out certain geometries of space-time, because we either will or won't see the same features mirrored on opposite parts of the sky, which means
Right.
light is going all the way around, and we're seeing it
But
from the
if
front and the back.
but if I understand this correctly, we pretty much can't make a more accurate measurement of the cosmic microwave background. We're literally, we can measure other factors in it, like the polarization of the light, but you can't just measure those temperature changes more precisely. We're at maximum. Planck sort of closed the book on that portion of it. So now the polarization is going to matter, and
Yes.
all which will tell us essentially which way these blobs were turning in the early universe, which is very interesting. Give us a sense of their interactions, and give us a sense of whether there was gravitational waves and primordial gravitational waves and so on and so forth. But we're going to have to measure that in between time, right? Like we really need that time from between 0 and about 10 billion years ago.
And this is where folks have hope for what was previously called the W first and is now called the.
The Nancy Grace Roman.
Thank you. I wanted
Yeah.
to say Vera Rubin because I am in love with that
Well,
telescope.
Vera Rubin will also help. So.
It will also help, but not as much, not as much. The Nancy Grace Roman telescope is really our next great hope for understanding dark energy. And of course, there is the JWST always lingering in the background as Schrodinger's telescope that either will or won't solve all of our problems for us.
Yeah, but it only does it like it'll solve specific problems. Like James Webb is when you need to call, when you've got something you need fixed, you bring in James Webb to take a good close look at it.
Yeah.
But Nancy Grace Roman is also in the infrared, but it's going to be observing vast swaths of the sky, huge chunks.
Yes.
Like it is, as with Vera Rubin, it is going to be able to see big pieces of the sky. So how will, and I'm trapped in Pamela's paradox now. We can't talk about the Nancy Grace Roman telescope because it hasn't launched yet.
Exactly.
And yet, in theory, it would be really interesting to know how it's supposed to work. But how can we do it? Anyway.
Yeah, but there's W bosons to discuss, and we haven't got there yet.
Yeah, well, that's going to have to be a whole other show because we're running out of time for this one.
All right.
Yeah. But the point being, like, all of these concepts, the Hubble constant, dark energy, dark matter, their interaction, their their proportion of the universe, they're all tied up together in this job of measuring the expansion rate of the universe at different times. And there is a giant gap that is about to get filled thanks to Nancy Grace Roman. But like, let's imagine, okay, so fine. So let's imagine that you wanted to launch a Hubble scale telescope. Something that's like the same size as the Hubble Space Telescope,
Like
but
W first.
was an infrared. No, but W first doesn't exist because it hasn't launched yet. But I'm sort of envisioning a hypothetical space telescope that has infrared capability. And let's say you launch it, say in about 2026 or so, that could do these surveys. How would it help in this project?
It's going to give us a larger perspective on all the little things that we're looking for. The discovering the supernova, the measuring the gravitationally lensed quasars, the looking for, Wendy Friedman is out there also observing massive red stars that flare. And it's going to give us this systematic understanding of also the distribution of the large-scale structure. So that thing that we're building on from the Planck observations of the CMB to our modern understanding of the structure of the universe, we're going to be able to get a much better understanding of how that structure has evolved over time. We started to get there with SDSS. Nancy Grace Roman is going to take us further than the Sloan Digital Sky Survey in its amazingness that Apache Point could ever do from the surface of our planet.
And in infrared, which
gets us further back in time.
SDSS can't do because it's visible light.
It's on the Earth.
Right. And so Nancy Grace Roman, because it's viewing in infrared, like James Webb, will be able to see the stuff that is farther and older.
Yes.
Which is that missing point in time. And then if it turns up any really interesting objects, cool early gravitationally lensed quasars, then James Webb can step in and give us a better look and measure the redshift to these specific objects with precision.
And just to be clear, it's not seeking supernovae, it is surveying the sky. And if there happen to be supernovae in there, cool. It will have the capacity to uncover these duplicate quasars that can get followed up, but it's out there measuring the large scale structure of the universe. And that's a pretty awesome job.
Well, that was good. I mean, it's hard to kind of like wrap together what this was, what we just talked about. But like, there is this crisis in cosmology. As astronomers have gotten better, it's awesome. As astronomers have gotten better at measuring, it has resolved itself. What were thought to be error bars that would resolve themselves have actually turned into a giant gap in our understanding of how the universe worked at the earliest times. But we don't have an answer, but at least we finally have a question. And I think that is enough to keep us busy and excited for years to come. Thanks, Pamela.
Thank you, Fraser. And yeah, we've got a lot of work to do. And we can keep bringing it to you here on Astronomy Cast. Thanks to all of you out there on Patreon who support us week after week and allow us to pay all of the people that keep us organized. I'm talking about Nancy, Rich, Allie. There are names I'm sure I'm forgetting. Beth. Why do I always forget Beth's name? I am sorry, Beth. Anyways, this week I would like to thank Scott Bieber, Matthias Hayden, Niall Bruce, Disastrina, Daniel Lucy, the Lonely Sand Person, Justin Proctor, Jim Schooler, Grigory Singleton, Paul L. Hayden, Jeff Wilson, Cooper, Aaron Segrev, Paul D. Disney, Kenneth Ryan, Nate Detweiler, Alan Moon, Stephen Shewater, Omar Del Riviero, Tim McMacken, Alex Rain, Benjamin Mueller, Don Mundus, Ninja Nick, Michael Reagan, Dean McDaniel, Scott Briggs, Matt Ruckner, Janelle Duncan, J. Alex Alexanderson, Father Prax, Philip Grant, Benjamin Carrier, Mark Whittick, Froda Tannenbaum, Antasor, Dwight Ilk, Mark Stephen Raznak, Abraham Cottrell, Shersome. I'm going to go with that. Bruce Amerzine, Gabriel Galfin, Dustin A. Ralph, Brent Krenop, Jim McGahan, GeForce 184, Kimberly Reich, Glenn McDavid, Stephen Coffey, and John Useth. And if you would like to join us and have the potential of me either pronouncing or not pronouncing your name correctly, join us over at patreon.com/astronomycast and feel free to add pronunciation instructions to your name. I
Or
love
don't.
all of you.
Or don't, if you want to laugh. Thanks, Pamela. We'll see you next week.
Thank you, Fraser. All right.
You're scratching your microphone somehow.
Hair.
I have no idea what you're talking about.
I have enough for both of us.
Okay. Do you have any questions on Twitch? We've got a few questions on YouTube, but I always go to YouTube first.
W boson now has not the predicted mass, so Zion is commenting on that. Seriously.
Did you want to? We were going to talk about that. Did you want to talk about that?
Let's save that for another episode.
Okay. I think I need Paul Sutter back to talk about that. In fact, I'm going to talk to him right now. Yeah. Okay. Cool. Moving on.
Yeah, I'm not seeing any specific questions.
Okay.
Although Richard Drubb is saying, I used to edit out the mispronounced names, but no more. It's become a thing. So Rich is so good at audio editing that he has, on more than one occasion, found the sounds I should have made and pieced them together to fix the monstrosity I created. And now he says it's an adorkable thing.
Yeah,
Rich is a really good editor.
Yeah, no, that's awesome. Mad props to your ability, Rich. But no, I think at this point, people know that you're going to wreck their name, and it's on them. Like if they want their name pronounced properly, or they want to just find out how this works, like here you take your best shot at it, then I think they need to, they can now take responsibility for this.
It's true. It's true.
Yeah. And then that could be an in-joke about our community, and they're completely resolved of having to learn how to pronounce every single name in the universe.
And as a reminder, we will not be here next week pronouncing or mispronouncing names. We are taking the week after Easter of Passover that also happens to line up with Ramadan this year off, and we wish all of you who are celebrating anything the insert adjective here week.
Enjoy your break.
Yeah, enjoy your break and stay safe out there during spring break, all of you.
All right. Arjun asks, what will happen for LIGO to help with this?
I don't think LIGO can help with this so much as potentially future.
Yeah.
I mean,
probably Lisa, maybe, or the Big Bang Observer will be the one that will actually do that.
Yeah.
So Lisa is the 3 gravitational wave observatories flying in formation in space, and they'll be able to detect these longer wavelength ones.
This is an eternally never launching mission.
It's going to launch.
They've been talking about it since I was in grad school.
Lisa mission. Well, yeah. So
it was supposed to have launched many times since I was in graduate school.
Oh my God, 2037 is when it's going to launch.
Yeah.
Oh. Yeah, no, for sure. We've been talking about this since I think the beginning of Astronomy Cast.
Yeah.
That's crazy. And so then the Big Bang Observer is a 12 version of Lisa.
There's no hope.
Which would then be able to detect the primordial gravitational waves generated by the Big Bang. The one possibility that's pretty exciting is the pulsar timing array, which is detecting
I'm loving
background gravitational waves through pulsar movements.
That's super creative.
Essentially, and essentially just the longer they measure these pulsars, the more they're teasing out background gravitational waves, but it's more like the waves of the ocean. Like you could
Yeah.
measure the existence of the ocean. If you had a buoy out in the ocean, you could measure the existence of waves,
Yeah.
but you wouldn't necessarily go, oh, I know where that wave came from and this wave, and I can measure that event. But once you've got, the frequency, sort of how much energy is passing by, you can start to get a sense of what kind of events were contributing to that. So I think that's going to be
Yeah.
our short version. Yeah, there was a test version of Lisa that was launched like what in 2017, I think.
Yeah.
No, when they launched the first test, the Lisa Pathfinder was back in 2015. So we've been 7 years since one of these spacecraft was launched to detect to see if you could test out all of the fundamental technologies.
Even my dogs are upset about Lisa.
Yeah. And so the Lisa Pathfinder, it was able to, the big key was, can it minimize the noise on the spacecraft to be able to detect the gravitational waves at a sensitivity required for the mission? And the Pathfinder blew it away.
Yeah.
So we now know that putting a gravitational wave detector in space is going to work like a charm. Now it's just a matter of getting to 2037 for the launch.
So
It is just forever.
I just had the horrible realization that we are now old enough that if we consider the typical life expectancy of humans without robot bodies, we have to ask, will we still be here for that mission? And it makes me sad. So I'm going to go to Seriously's question. Cersei asks, can the Webb get a spectra from Arendal or the new farthest galaxy? So do you know what Arendal is?
Yeah, the new farthest galaxy.
Yeah. Well, it's the star. It's an individual star.
Oh, right. It's the individual star that was seen through gravitational lensing.
Yeah.
Yes.
Yeah, it's the new furthest individual star.
I'm going to guess yes.
Yeah, I think I remember reading that in the press release. Now, that doesn't mean it's a good spectra, but it should be enough to tell us its redshift, but not necessarily its composition.
Yeah. I wonder how much light you need to actually break it up and figure out what it's made out of.
I don't want to do that calculation.
Yeah.
So AstroWise is wondering if all my house washing and stuff is done. Last week we had an episode that was tortured by the yard and gutter cleaners that ran 5 hours late and then ended up coming back all day yesterday. They have still not power washed our house. So at some point, humans are going to arrive to power wash our house, but I'm still dealing with less noise than poor Fraser has with all the construction on his property.
Well, the noise is not the construction on the property. The noise is all the noises that a trailer makes.
Yeah.
So,
yeah.
But yeah, the furnace going off, the refrigerator that's right behind me, the pump that's right under my computer makes a noise every now and then. The hot water tank that turns on. Yeah. We're
counting the days.
Carla cannot wait to get the hell out of here. Okay.
Okay, I'm not seeing any more questions over on Twitch.
So, Hal McKinney asks, do high and low tide apply to the Earth's ocean of air similar to our oceans of water? What a great question.
I don't know if they apply to the air. I know they apply to the land. Like, you have to take into account the rise and fall of mountain peaks when figuring out pulsar timing.
Yeah. So it has to, right? Like the ocean of air has to squish and.
But the question is that noticeable in relationship to all of the magnetic effects that it's dealing with? What is dominant, tidal or magnetic at that altitude?
Um, okay, so I'm reading a paper now called Atmospheric Tides. And
That's
atmospheric tides
cool.
are ubiquitous features of the Earth's atmosphere. They are persistent global oscillations that are observed in all types of atmospheric fields, including wind, temperature, pressure, density, and geopotential height. The oscillations have periods that have some indicator of a solar or lunar day. They have 24 and 12-hour periods, and they've been studied for many years. And I don't see what the height difference is. I'm sure it's in the paper, but I don't see it quickly.
But it exists. It's a thing.
Yeah, dependence on time of day, interaction with mountains.
So hurricanes are getting yanked up and
300,
down by the tides.
300. Okay, so here we go. The diurnal tide is observed to propagate up to 110 kilometers in the low latitude thermosphere before being dissipated by molecular viscosity. The semi-diurnal tide, with its much longer vertical wavelength, can extend to higher altitudes, reaching about 300 kilometers. So, and planetary waves have been observed in the lower thermosphere. Really interesting. Here, I'm going to put
Yeah.
this paper
If you
in
put it in
the
our chat, I can put it on Twitch as well.
Okay, sure. Let's see if this works.
This is where you all see that my chat is behind where the camera is right now.
All right, so here's the paper, and I'll put it in YouTube.
Oh, she has such loud opinions. That's Stella, everyone.
Right. There you go, Hal. So dig into it.
Can I ask?
Arjun asks, there was talk of a telescope that used a liquid lens. Was that one of the NIAC grants? So no. So my understanding is, are you familiar with this, the liquid telescope?
So
No?
I know there used to be a liquid mercury telescope up in Canada.
No. This is brand new. So there's a researcher from NASA who's working on an idea of essentially using liquid in space to act as a lens, and you would
Oh,
essentially
that's cool.
push the lens into a shape,
Mm-hmm.
and in theory you could have a 100-meter telescope that's made of liquid that would act like a telescope. And I don't think there's a NIAC grant, but NASA is investigating it. But there's an experiment that's going up to just arrived at the International Space Station as part of the Axiom space crew.
Yes.
So the 4 private astronauts who've arrived at the space station,
And are
they're going to
doing
be carrying out
science.
Yes, and they're going to be carrying out a whole bunch of science experiments,
Yeah.
and one of them is going to be this testing out this liquid telescope in the space station to see if the idea is feasible. I've actually reached out to the researcher to see if he'll talk to me and do an interview with me. So, in fact, you know what? Now I'm going to nag him. So I've already queued up an interview with Paul to talk about the W boson, and I will.
So Cersei asks while you're typing, what is the liquid?
I think they originally tried water, and then they found that like a certain kind of oil was going to work.
Yeah, that seems better.
Yeah, fluid telescope. There we go. All right. Okay, so that's.
I have to say, the Axiom program is deeply pleasing because it is people using personal money or investor money to enable science by people who otherwise might not ever get to do it for a variety of reasons. And this is not just going up and coming back down for the roller coaster ride of it. This is training, work, doing amazing things. This is the difference between going to Borneo and going on a safari, and going to Borneo as part of an Earthwatch program and working with scientists, getting your hands dirty, helping to benefit the world. And it's just deeply pleasing. I don't even know if Earthwatch still exists. I should look that up before I go promoting something that was cool in the 90s.
All right. It's going to be the tag team Hal McKinney Arjun questions if someone else doesn't jump in here. So Arjun asks, would a higher resolution cosmic microwave background radiation help, or is it as detailed as we need? So it's as detailed as can be. And this is I did an interview with Paul Sutter couple of years ago, and I forget the name. Is it cosmic invariance? There's a term. I don't know if it's cosmic invariance. Nope, that's not it. There's a famous blogger used this term, and the gist being that we can't get any more information out of the cosmic microwave background.
Is that Sean Carroll?
Is it Sean Carroll's blog? Nope, that's not it. I forget what it's called. Anyway, there's a term. Maybe someone who's watching can throw it in there.
Earthwatch still exists. I can offer that much.
Great.
So Keeper of Masks over on Twitch is asking, do you think SLS is going to actually do their test on Thursday?
Sure. Why not? Why not? I mean, they pushed it back a couple of times.
Yeah.
So, but there's no reason to believe that it won't eventually work.
So I'm starting to feel like SLS is like me and solar eclipses. There's always going to be weather, conflict, miscellaneous thing that has nothing to do with the rocket that fails. There's always going to be a reason it just never goes. Until one day it does, but it just feels that way. And then Keeper's like, follow-up question, is he willing to put money on that?
Sure. It's like James Webb, right? Like it doesn't feel like it's going to launch, and then it launches, and then it's perfection.
They're expecting
like, think about it.
rain on Thursday.
Isn't it blowing your mind that we have gone from a facility in California through the canal to the launch facility, launched off of an Ariane 5 rocket, multiple boosts. It's arrived at its destination. Every actuators work perfectly.
Don't curse it. You're gonna curse it.
I'm not going to curse it. It's fine. And so far, like the MIRI instrument is coming online. We're almost there.
Yeah, I'm just looking at the weather and it's supposed to rain. I really do feel that this is starting to become like me in solar eclipses. I learned something new this weekend. The 2023 annular eclipse passes over Roswell, New Mexico.
Yeah.
And that's 24? Just delightful. No, that's the total eclipse. There's a 20
an annular?
Yeah, there's an annular that I'm going to screw up the past. There's both an annular and a total that are about a year apart. They cross in South Texas. The total is the one that goes all the way up to Canada.
October 14th. Okay.
Yeah. So I feel like the best and most ridiculous photos of the annular are going to come out of Roswell, and I just need to share this information with others.
That's exciting. Yeah, I think it'll work. Like, in the end, it's going to work. I mean, it'll launch when it launches. It's the wizards of rocketry. But NASA tends to make absolutely 100% sure that this thing is going to do what it's supposed to do, while SpaceX just goes crazy, just goes all in with both feet.
I'm team iterative design. I've said that before. I will say it again.
Yeah. I much prefer the iterative style than the cathedral approach.
Yeah.
It's a horrible mistake to take all this time
without having been one basket.
Yeah, to have been able to test all this stuff. Yeah, it's madness. So Um. Okay. What else we got?
AstroWise says, I don't get out of bed for an annular.
I'd watch an annular eclipse. I wouldn't travel. I would get out of bed though, but I wouldn't travel to, 1,000 kilometers to see an annular eclipse.
All right.
Would I travel 100 kilometers? No.
I would travel 2 hours, which is variable
About 100
distances
kilometers.
depending on
Yeah.
where you are.
Yeah. So you would travel 2 hours to see
Yeah.
to get under totality of an annular eclipse.
Yeah, photo practice.
Sure. I guess. Okay, we're out of time. Pamela, what are you
Yes.
working on?
I am daily space this week. Next week we are off. And as always, we're going to be working on planning upgrades for the future. I'm also going to be this week doing some digital art in the evening, working on building solar systems with 5,000 new worlds out there. We need to start imagining them as fast as we can.
Hurry. So let's see. So I've got my open space tonight where I'll be answering people's questions. I've got a live show today at 2. I'm interviewing Dr. Thane Curry, who is with the Subaru telescope, and they're the ones who observed this new giant planet, the direct observation. And we're going to talk about direct observations in general. I've got an interview with Dr. Surjit Ranjendran on Thursday, and we're going to be talking about like possible explanations for dark matter. So he's a professor at Johns Hopkins University, and focuses on sort of like what comes after the standard model. So that's going to be kind of cool. Yeah, and then of course we got the Week Space Hangout coming out on Wednesday. So
It's true.
Again, the news, the space news is just disgorged in your general direction.
And we will bring it to you in different formats so you have no excuse. There is
No
always
excuse.
a format for you to get science. Yes,
Perfect.
that was a threat.
Science it up. Yeah, threatening people with science. All right. Well, thank you, Pamela. Thanks, everyone, for watching us today. Thanks to all the moderators. Thanks, everyone on Twitch and on YouTube. Thanks to all of the editors, producers, organizers behind the scenes that keep us organized. And Pamela, thank you for bringing the brain. And we will see all of you next week. Thanks, everyone.
Bye, everyone.